Okay, so let's look at a couple of other examples of how to compute the expected value. The first one we're going to look at is the expected value of a lottery ticket. Okay, so this is from a couple of years ago, and at that point the Powerball jackpot in the U.S. Was 675 million U.S. dollars. Okay, and the chances of winning with one random ticket was roughly 1 in 292 million. If each ticket costs $2, what is the expected value of a lottery ticket? Well, okay, so let's go over back to our expected value calculator and try to plug these numbers in. So, okay, so obviously here there are two possible outcomes. You could either win the lottery or you could lose the lottery. Okay, so if you win the lottery, you would get $675 million. So I'm going to put $675 million. So, with these cells, you want to type in an equal sign, okay, and you want to put in the number. So $675 million. And actually, technically, right, it's $675 million minus the $2 that you paid for the lottery ticket. So we're going to subtract 2 from that, okay? And what is the probability of that? That probability is 1 in, I'm just going to round, okay, so I'm going to say 1 in 220 million. So, I'm sorry, 292 million. Okay, so the probability of that is going to be equals 1 over 292,000,000. Okay, and you can see that it's like a very small decimal value here, 0 followed by 0.00, a bunch of zeros there. Obviously, it's very unlikely that you would win. Okay, now what happens in the other case? Well, if you lose the lottery, I mean, nothing bad happens to you if you lose the lottery. It's just that you would lose the $2 that you spent on the lottery ticket. Okay, and what's the probability of that? Well, the probability that you're going to lose is simply, 1 minus the probability that you'll win. It's 1 minus this very small probability. So I'm going to say equals 1 minus, okay, and then I'm just going to click on that probability, and it'll do that calculation for me. Okay. By the way, I'm assuming that you have a little bit of experience with how to use these spreadsheets. Okay. Remember that if you're putting something into a cell, right, and you want it to refer to another cell, right? So I would say here in this case, I would type in equals, and then I would just do 1 minus, and then I would simply click on the cell that I want to reference. So in this case, I want to do 1 minus the contents of this cell, F3. Okay. So I press enter. And okay, there I get my result. Okay, and so this column has already been set up for you. It automatically multiplies these numbers, and so you can see that this number here is this number times this number. This number here is this number times this number. I add these two numbers up. There's my expected value, 0.31. So. Okay, so what we're saying here, so perhaps surprisingly, is that the expected value of this lottery ticket is actually positive. The expected value of this lottery ticket is 31 cents. Okay, so that's not bad. Now, does this mean that everybody should have gone out and bought this Powerball ticket? Well, no, not necessarily. First of all, people don't always follow this idea of maximizing expected value. And as we'll see in the next mini video, there are actually a couple of situations where it appears that it doesn't really even make sense to follow this rule of maximizing expected value. Okay. For another thing, there are a couple of situations that we're not taking into account with this calculation. Okay. Number one, and perhaps most significantly, is we're not taking taxes into account. When you win the lottery, if you want to be paid off, as a lump sum, there's a lot of taxes on those winnings, close to 50%. Okay, so your payoff in the situation that you win actually is probably closer to this number divided by 2. Okay, and if I were to put that in, okay, well then you can see my expected value is in the red. It's quite negative. Furthermore, there's also a probability, albeit a small one, that you and another person could have both chosen the same winning lottery number. Okay, in that case, you guys would split the winnings. So there's actually a third outcome here, which is that you win, but split the pot with somebody else. Okay, and so we'd have to take that into account as well. Okay, so point being is you don't necessarily want to go out and buy a million Powerball tickets. Okay, but again, we're just going through this example of how to do this calculation. Okay, let's do one more example. So this example comes from something which is very dear to my heart, which is the game of Monopoly. I love the game of Monopoly. I enjoy playing board games in general, but I quite like the board game of Monopoly. It's the first board game I ever played as a child. Okay, and Monopoly draws some mixed opinions. Some people don't like it because it's really slow. But whenever you think of Monopoly, I'm sure you've played a few times before. And as you know, the way the game works is you buy up these properties on the board, and then when somebody else lands on that property, then you get paid a certain amount of money. Okay, and one of the interesting properties on the board are a set of properties called the utilities. There's the electric company and the waterworks. Okay, and the way they work, it's a little bit different. When somebody lands on them, instead of always paying the same amount every time, it's kind of random how much you get paid. What happens is if you own one utility, that is to say you own either the electric company or the waterworks, the rent, or the amount that they have to pay, is 4 times the amount shown on the die. If you own both utilities, then you're paid 10 times the amount shown on the dice. Okay, so now you might be thinking to yourself, well, how good is that? Is that worth it to be paid 4 times the amount shown on the dice? And how now remember, it costs $150 to buy this property in the first place. So given that you're going to be, it costs $150, I mean, how long is it going to be essentially before you sort of can break even on this property? Okay, so we're gonna look at that. Okay, so so let's look at this example over here. So you can see, so first of all, unlike the previous examples, there's a large number of outcomes in this situation. Because if you roll 2 dice, like you do in Monopoly, there are a good number of outcomes, okay? You could get anything from a 2, so rolling a 1 on both dice, up to a 12, or rolling a 6 on both dice. Okay, so there are those outcomes. And then the probability for each one of these things is actually different. Because, well, for example, 7 is the most likely roll because there's a bunch of different ways that you could add up to a 7 with 2 dice. You could get a 3 and a 4, a 2 and a 5, a 1 and a 6. Okay, so 7 is quite likely, whereas, getting either, snake eyes, 2 1s, or 2 6s to form a 12 is very unlikely. Okay, now you go, how did I get these probabilities? You can compute them manually, okay, but I sort of cheated and I just looked up what the probabilities are on the internet. Okay. So here are those probabilities, and then so the only thing we really need to fill out here is just the payoffs. Okay, so let's assume first that we own one of the utilities. Okay, so if I own one utility, my pay is 4 times the amount shown on the dice. So if they roll a 2 and then land on my property, I'd be paid 2 times 4, or $8. Okay, again, how am I filling that in? I simply select the cell, I press equals, I click over here, I click my 2, and I say times 4. Okay, so I get an 8. And then we don't want to manually have to do that every time. Okay, luckily we can compute the rest of these very easily. I'm just going to take my mouse, I'm going to mouse over this little square cell right here. My cursor turns into a plus sign, click, and drag all the way down, and you'll see that the computer will perform that calculation for every single cell. Okay? So then, same thing as before, I take my payoff, I multiply by my probability, I get this number, I do it for all of those, I add up those numbers, I add up this whole column of numbers, and I get $28. Okay, so the expected value when somebody lands on your waterworks is $28. Well, so how good is that? Well, one way you can think about it is since the property costs $150, it's going to be roughly 5 times, that is to say, somebody will have to land on your property 5 times before you break even on the electric company. Okay? How good is that? I mean, honestly, that doesn't seem that good to me, right? I mean, somebody has to land on it 5 times for you to even break even? Maybe that doesn't seem that good. Okay? But the situation changes quite a bit if you own both utilities. Okay? Because then all of a sudden you're paid 10 times the amount shown on the dice. Okay, so let's change this calculation to reflect that. So I'm going to go into this first cell here. I'm going to delete it. Okay, just press delete. And then I'm going to say equals. And then instead of doing 2 times 4, I'm going to do this, select this cell A3 times 10. Okay, so now I get a 20. And then I'm just simply going to drag this whole thing down again to update those numbers. Okay, so now you can see all of these are being multiplied by 10. And all of a sudden, now my expected value is quite a bit better. My expected value is now $70. Okay, well, that's a lot better, right? Basically, that means that somebody only has to land on your property twice in order for you to break even and start making money on that property. Okay. Okay, so now, with all of these calculations, okay, everything that I've done so far, there are, of course, some things that we're not taking into account, okay? For example, here, I haven't taken into account the fact that if you own both properties, it's twice as likely that somebody will land on one of them, okay? We haven't really taken that effect into account. When we were thinking about the poker example, okay, we didn't take into account the probability of other hands, right? So, for example, we calculated the likelihood of a flush, but there's actually some probability of getting a straight flush. We also didn't take into account what the other person might have, right? With poker, it's actually possible that both you and your opponent will have a flush. In that case, you got to go to sort of the tiebreaker. I mean, so you know, none of these calculations are necessarily 100% accurate, okay? But I think they're enough for you to get the general idea, and enough for, most importantly, for you to understand what the process of calculating this expected value is. Okay. Okay. So in the next video, we're going to look at some situations where it seems like people either don't follow the rule of expected value, that is to say, Amy Duke's strategy of essentially maximizing the expected value, where people don't follow that, and even some situations where it appears that it might not be rational to follow the rule of expected value. Okay, so I'll see you in a bit for those.